Alright, welcome to the fifth talk on Foundations of Mathematical Proof. Today is just going to be a short little spiel on quantifiers, so I'm just going to talk about what they are. So, quantifiers. Quantifiers are phrases added to an open sentence to make them statements. There are two main quantifiers that we'll be working with. There's for all, which is denoted with an upside down A. And we have there exists, which is denoted by a backwards E. So these are only the two quantifiers. So if you remember back a couple of videos, we had an open sentence that was P of X is X is equal to 9. So we could have for every X, you would probably have for every X in natural numbers, X is equal to 9. And you'd see that would be false. But you could have there exists an X in natural numbers such that X is equal to 9, and that would be a true statement. So you add quantifiers to open sentences to make them statements. And here's how it'd be. Let P of X be an open sentence over domain S. For every X in S, that is just shorthanded with this upside down A. And there exists X and S, P of X is noted with the backwards E. So we just shorthand using the upside down A and backwards E, and I will probably use that in future videos, so make note of that notation. And last thing I really wanted to do was go over negation for these and a lot of negations. So the negation of P or Q is equivalent to not P and not Q. The negation of P and Q is equivalent to not P or not Q. The negation of if P then Q is equivalent to P and not Q. The negation of the universal quantifier, which is the for every. So the negation of for every X P of X is equivalent to there exists an X such that not P of X. And likewise, the negation of there exists X P of X is equivalent to for every X not P of X. So those are just negations. I had a couple of previous ones up there just for review, and I had the ones for the quantifiers. So that's all I have. Next video we'll get into actually some definitions that'll help us go into proving things, and we'll get into some more proofy math. Alright, thanks for watching.